he joined
Okay,
because
okay, okay, sir.
so we are starting now. Prakash, I hope the screen is visible and the screen will be visible now. Okay,
Sir.
so, so I will take the PPT. So I'll be teaching you today the introductory class. It's a preparatory class for introduction. Okay, so let me take the PPT. Okay, good afternoon, students. So this is the subject called electrical drives and control. This is taught for second year mechanical automation as well as mechanical engineering students. So this by this preparatory class, we are trying to make some interest, bring some interest in you, your students, to know about the subjects and be ready with the subject whenever our regular classes starts. Okay. So by this preparatory class, it is basically an activity-based session. That means you can actually see where the subject is applied in engineering. So the application of electrical drives, you can see by doing some activity. Okay, let us say in an engineering subject, usually we will be doing the theoretical study, then we will do the calculation, and to further extend, we will do a simulation. After simulation only, we will go for some hardware projects. Okay, so எடுத்த உடனே நம்ம வந்து we may not go for the hardware. Okay, so first you need to understand the subject, then you have to do some design calculation, then you have to simulate it using some simulation environment. Okay, so we will see that simulation environment in this preparatory class, and if possible, we will try to do some hardware. Okay, so by this classes, we will give some introduction to that, right? So basically, the textbook they are referring to is Vedam Subramaniam is this textbook referred, and you have NPTEL course also. You can see here there is a link here. Okay, so if you open that link, you can see. I will just open it for you. Okay, just open and different windows seems. Take that. We copy it from there itself. So by Anna University only you have electrical drives and control, but let us say by the IIT Delhi they are providing a course called industrial drives. Okay, it will be very interesting because the way they are describing the drives will be different from whatever Anna University syllabus they are providing. Okay, so here if you see they are explaining the initial drive system, electrical system, coupling and mechanical. So you can see there is a connection between electrical and mechanical. So in between you have electromagnetic field. Okay, so this electrical system is coupled to mechanical system. So there is an electromagnetic field in between. Okay, so we are going to study about. Okay, I'll close this window. So we are going to study about electrical side in detail. So where we can do the application in the electrical system where it is applied, and the mechanical system where the mechanical system is happening. So basically, you are from mechanical engineering, so you will be studying the mechanical system in detail. So it is important to know the coupling between electrical and mechanical. Okay, so in that aspect we will study. Even though if you remember about a drive is something like motor and a load. It's a combination of a motor as well as a load. It is coupled with some shaft. Okay, so whenever we say a drive, whenever we are explaining about a drive, that means there is a motor and there is a what is that called, some load in the sense it can be a gear system. So there are so many loads, right? So any of such loads will be there, right? So let us say I'll go to the presentation. So by NPTEL course you can easily get some understanding. NPTEL course வச்சுட்டு உங்களுக்கு அதை பற்றி ஒரு ஐடியா கிடைச்சிடும். அப்புறம் பார்த்தீங்கன்னா அந்த டெக்ஸ்ட் புக் பேங்க்ல என்ன கொடுக்க போறோம்னா யூ வில் பி கெட்டிங் எலக்ட்ரிக்கல் டிரைவ்ஸ் அண்ட் கண்ட்ரோல் ஞான வடிவல் டெக்ஸ்ட். ஸோ இந்த டெக்ஸ்ட் புக், இன் திஸ் டெக்ஸ்ட் புக் தே வில் பி கிவன் எவ்ரிதிங் based on Anna University syllabus. Okay, so Anna University syllabus, whatever they are given, that you can easily obtain from this textbook. Okay, so what our motto is to study the application of electrical drives and control. So in the future, if you see, if you take the future of electrical drives and control, where it is applied, so there is going to be electric vehicles in the future. So we know that fossil fuels like petrol, diesel, all these fossil fuels are getting costly day by day. Older days, I remember the cost of diesel is 40 rupees, petrol is 60 rupees. Now it is like 70, 80, even sometimes we have seen hike in till 90 also sometimes. So future, the demand of petrol, diesel is going to be increasing, because demand increases means cost also will increase. Okay, because the supply is very low, supply is going to be exhausted. So we have to find some alternative, we have to find some other methods of mechanical power generation. So you can see this car is a machine, it's a machine basically. So it is, if we are giving an input to the car, so normal days, today we are giving petrol IC based engines, internal combustion based engines. We are giving petrol and or diesel, and we are getting mechanical output from it. Okay, but if you compare the electrical systems, your household appliances, your whatever industrial loads, so most of the loads are working under electricity. So why we are not using electricity for the transportation? So isn't it possible to use electricity for the transportation? So that is the angle we are thinking. Now it is possible, but the problem is with the battery. So wherever in our household we have transmission lines, power is coming from the transmission line and we are receiving it using some wiring system, right? It's already connected to the utility grid. You don't have to worry about battery there, unless there is a power cut. That too, we are using some lead acid battery of small capacity. But if you trying to take more power like a machine, like a car, so in a car you need more power, that means you cannot directly connect it to the grid. You cannot take the wire to the car and the car will keep running with the wire. It is not possible. So you have to store it. So the problem is with the storage. So there are research going on to store the batteries, how to store the more power in a battery. Lithium-ion batteries, whatever battery we are seeing in your mobile phones, is the same cell we are using in the car also, but its design will be different. Its power capacity will be different. That means it can deliver more power if you charge it for more duration. So the charging time also matters. In your cell phone, you can charge your cell phone like fast charging is available nowadays. But the problem with such technology is it may damage the batteries. If you charge your batteries for fast charging mode, the chemical reaction happening is rigorous. Inside the chemical reaction is very rigorous. It will get heated up. So because engineers should reduce the heat. Okay. So when the battery is heated up, its life will be reduced. Whatever things, let us say human beings also, if we are exposed to some high temperatures, our life will be reducing, our age will be reducing. That is the fact. Similar to that, all the object also, if you are exposing to high temperature, its age will be, its lifetime will be reduced. So we have to, engineers should try to reduce the heat also. So that is the area of research, how to store the batteries, how to store electric energy into the batteries. Okay. So in the slide you can see an electric car. So the car is parked in a place. Let us say somebody is bringing that car to his office. Let us assume in front of that building is an office, and he is parking the car near to the charging point. You can see the charging point is very minimal, very small design, and it is taking power from the office itself. Okay, so the charging only the connection wire. Okay, is coming to the car and is connected to the car. So by the time he is leaving by evening, let us say morning 9 o'clock he has come, and he will leave the office by 4 o'clock or 5 o'clock. So the car will be fully charged, and he can go back or he can go to some other places also. So the mileage also matters. Okay, mileage in the sense in electric vehicle, mileage is on one charge how much distance it will come. So they have overcome that issues, the mileage problem of the car, everything they have overcome. But when they overcome all these problems, the cost become the barrier. So cost become too high. So nowadays, let us say first car was an electric car. When they built a car initially in some 90s, not 90s, even before. Okay, first electric vehicle, it was like after the horse carrier, they tried to build one motor vehicle, but that motor vehicle was actually powered by electricity. So initially it was electric car. Then somebody invented internal combustion engines, and they installed IC engines into the car. Then it become very easy if you fill the petrol, or initial days it used to be diesel only. So when you fill the diesel, the car can go to any places. Okay, so it was very interesting initially, that it was very wonderful. IC engines started moving the car. Okay, so the thing is, the problem nowadays is the fossil fuel. Diesel is going to be exhausted. Diesel is going to be finished. Okay, when the diesel is going to be finished, what can we do? How can we run the car? Another problem is the emission. The heat generated from the internal combustion engine. If the combustion is not complete, you know that in the internal combustion engine There should be proper amount of fuel, there should be proper temperature, there should be all the conditions satisfying complete combustion. So if the combustion is not complete, the emission will come into the picture. Emission in the sense carbon dioxide, carbon monoxide, nitrogen dioxide, sulfur dioxide, all these inert gases, all these highly reactive inert gases, highly reactive as well as some inert gases will come out. So if these gases are coming out, it will contribute to global warming as well as greenhouse effect. Both are different. Global warming is the temperature of your atmosphere going to be increased year by year due to the absorption of solar radiation by the carbon dioxide. So we assume that whatever sunlight coming to the earth is reflected back to the space. Some percentage is only trapped in the atmosphere, but now the trapping of heat in the atmosphere is more. That is your global warming. So when that happens, the ice in the Arctic areas, you know that our earth is filled with water. On the top layer you can see land is very small, but water is the major part. Further, you know that poles in the North Pole and South Pole, water is in the form of ice, and it is actually deposited like mountains. Okay, glacier, mountain of ices, glaciers are there. So when the atmosphere gets heated up, it will start melting. So year by year, your water level is going to be increased because of emission, because of carbon dioxide emission, because carbon dioxide will retain more heat, and there is going to be some unbalance in the initial equilibrium of ecosystem. So whatever ecosystem we are living in will face some unbalance. There is something called ecological balance, but because of this carbon dioxide, there is going to be some unbalance in the system. So the water level will increase, and your seashore areas will face these increased water levels, and the land is going to be very less. There is going to be some disasters happening. So that is there. Okay, and because of that is because of global warming, because of greenhouse effect, carbon monoxide, nitrogen dioxide, sulfur dioxide, and some freon gases. So some gases, such gases will, when we are exposed to such gases, it will damage the ozone layer. Ozone layer, you know, it is made up of oxygen. It is O3 molecules. It is an oxygen, three oxygen molecules combined, O3 molecules. Now these gases are highly reactive. Okay, so this let us say like chlorine. Chlorine, you know, it is highly reactive. Similar fashion, this nitrogen dioxide, carbon monoxide, everything is highly reactive. So when these gases are, let me see, somebody's asking. Okay, so I have admitted. Okay. Welcome, sir.
Yeah, thank you, sir. Thank you, sir.
Okay.
Continue, sir.
Yes, yes. So in the future, we are going to have electric vehicles. Okay. So when this, because of global warming, the emission from the internal combustion engines, the air is going to be heated up. Global warming is going to heat the air. So we want to get rid of internal combustion engines, and we want to transform the vehicle industry, transportation industry into electrical vehicles. Okay. So we can see a car is charged in his office. So morning he is coming with the car. He is parking the car near his office, and he is charging the car from the office itself. Okay. So by the time evening he has finished his work, he can go back to his home, taking that car. Now the advantage of this electric vehicle is there is no need to buy petrol any further. We don't have to worry about buying petrol and diesel. Okay. Another advantage is we don't have to worry about the emission. There is no emission checking, and everyone will accept electric vehicles. It's a sign of a prestige. So you know that people are buying different car. Okay, even though its functionality is same, to take people from one place to another place. You know there is a range of car, okay, available. So why we have such a range of cars? Because it's a comfort in the car, it's the features in the car, okay, it's the prestige. Some car you cannot buy, even though you have money, you cannot buy the car because it is allotted to people who are very much reputed in the society. So similar fashion, electric vehicle is going to be a reputed vehicle because it's going to be emission free. It's not going to pollute the environment. Okay. And another aspect is electric vehicles are very much soundproof. There is not going to be any sound in the vehicle. And once you charge the vehicle, it can go to distance of like 1,000 kilometers. So let us assume I want to go from Chennai to Kerala. After one charge, after one night of charging the car, I can take it to Kerala very easily. So if you see the distance covered also, 1 kilometer, it can go, let us say, 1 rupees of charging. So 1,000 rupees maximum, 1,000 kilometer, I can go with the 1,000 rupees, even less. Sometimes electricity is going to be very cheap. That you can take your car to your home very less amount. Okay. So by the single charge you can go to long distance. Only problem as I was discussing is the battery. So you should initially buy the battery, that is going to be costly. So we are having lot of research on electric vehicle battery. Okay. So lithium ion batteries, whatever battery you are finding in your mobile phone. Okay. Similar batteries of very big batteries will be present inside the car. Okay. So such a car is going to be the future of future of engineering in the transportation also. Similar to our home appliances, we will be having transportation also with electrical vehicles. That's the point. Now, assume you are going to design a drive for that. So drive, as I was telling, it's a motor and a load combination. So in this car, your motor will be there, PLDC, brushless DC motor will be there, and there is going to be the car wheel. Okay. So if you give an acceleration, actually what you are doing, you are increasing the speed of the motor. Okay. So you have to know the speed control methods. What are the speed control methods in the motor? Okay. So that is one thing. Another thing is you should know the load characteristics. Okay, so what do you mean by characteristics? Characteristics means you are going to buy one motor for an industry. Let's say you are an engineer in an industry and you want to buy a motor for your industry. You should know how to calculate the motor for that industry. What is the capacity of the motor? So before buying, you have to understand the characteristics of the load. So in your industry, let us say you want to pump water to a height of 100 meter. You are going to pump the water because in industry, everywhere you need water. Somewhere we are using water as some methods like fluid braking system, pneumatics, or a cooling system, water cooling system. Wherever it is, you have to pump the water. Okay. So you want to calculate the load requirement of the pump. So you have to first initially do the calculation. So when you get the calculation, finally you get the calculation with the HP, okay, motor capacity you will get. But the problem is when you are changing the load. So it is all pumping and all is a flat load. The requirement is steady for long duration. But there will be loads like crane, let us say crane, electric overhead travel we say. So that crane will have a varying load. That means when we are trying to lift some weight, it will face a different, it needs different power, more power when you are lifting. It needs less power when you are dropping the load. Okay. So there you need to know the characteristics. Characteristics means the profile of changing power. Okay, before buying the motor itself, you should know that. So once you have the characteristics, you must see what is the highest power requirement. Okay, and you have to see the capacity of the motor based on that. But you cannot buy a motor because the highest capacity is for some duration. It is having highest capacity. You have to design a motor, a separate drive system also for that with the gear arrangement. Okay. So gear arrangement and all you will study in the mechanical engineering subject, different subject. But what I mean to say is you have to buy the proper motor for that application. Okay. So for that reason, you have to do the calculation, right? You have to find the load profile of the industry, and you have to do the calculation, and you will get a value in horsepower. Your motor capacity is always measured in horsepower. So 1 horsepower is equal to 740 watts. So horsepower வந்து mechanical unit சொல்லுங்க. We can say it as mechanical unit. Watts is the unit of electric power. Okay. So that is electrical. So 1 horsepower if you say that is for 740 watts. Okay. So that means you should know how to deal with the horsepower, watts, and you should know how to design a drive system for let us assume it is an electric vehicle or an industrial loads. So the thing is, by this subject, overview of the subject is you will know how to design an electric drive. Okay. You know how to control the speed of an electric drive. You will know how to control the torque, calculate the torque requirement of an electric drive. Okay. So all these things are studied by this subject, and in that electric drive you have DC and AC systems. DC is it's all direct current. You will say all your in your train, train, in train we are using 110 volt DC. Why you are using 110 volt DC? Because we have battery system in the train. Okay. So if we are using 110 volt DC generator, we can store that battery pack easily, and you can take the power easily from the battery pack when the train is stopping. Okay, when the train is stopped, it can be easily taken. So nowadays we have AC system possible. You can use a separate inverter system, and you can you can generate AC voltages. But we are following 110 volt DC in your train. But if you see in our home, we are using inverter system. So there we are using AC voltage. Why? Because our appliances are AC. 230 volt fan is working under 230 volt, bulb is working under 230 volt. So you need an inverter. Okay. So similarly, your motor also. Motor can be operated in DC supply as well as AC supply if the motor is DC or AC respectively. So if it is a DC motor, you can give a DC supply. Okay, but we cannot give it directly also. We cannot give a 230 volt, 220 volt DC directly to a motor. So we will discuss that in the coming preparatory class sessions. We will discuss why we cannot give a DC directly to a motor. Okay. Similarly, you have AC motor. You can operate an AC motor by giving AC supply. So, by this subject, we want to realize what is the motor we are using in your electric vehicle. Why we are going for a AC based system or a DC based system, and what is the advantage of using certain motors like brushless DC motor. If you are using brushless DC motor, there are so many advantages. So whether we can go for a brushless DC motor or a brushed DC motor in an electric vehicle, such scenarios we will discuss. Okay. So let us. Okay. I want to bring to your notice that in October 2015, okay, October 2015, 6 years back, almost 5 to 6 years back, Chevrolet Volt, this is a branded electric car, okay, it's a plugged-in hybrid. Hybrid means it can work on diesel as well as electric, okay. That means if you charge it, it will run, or if you pour petrol, diesel or petrol, then also it will work. Okay, that car is sold for like 1 lakh unit. That means it has crossed that time itself. It has crossed. This much unit has sold that time. People bought that vehicle. Okay, because it is a combination of electric and fossil fuel, petrol, diesel. Because once you don't have petrol, you can use the battery stored energy. Once your battery stored energy is going to be finished, you can go for diesel. So usually why people will buy, because they will charge the car, they will drive it for battery operated mode. Okay. As far as possible, they will drive it in electrical charging discharging mode. So under battery it will operate, because they can save the petrol here. You can see if they are driving the car for electricity charging, then they don't have to use the fuel. Okay. Or let us say you are going for a long distance without any turning. Let us say like roads in here in our Salem or wherever we are going, you can see straight roads, right? So we will have roadways. So there you need to run the car for long distance without any acceleration. At that time they will use for electric vehicle, electric discharging mode, battery mode. And when there is a turning or there is a acceleration required, or there is something like a hilly area, there they will change it to hybrid, internal combustion mode. Okay. So in such a way you can use this vehicle. So that is also possible, right? So that is the world's top selling plug-in hybrid, Chevrolet Volt. It was happened already in 2015, right? So this subject is very important, because future is going to be electric vehicles. 2019, Ola in Indian city. Okay, so 1 second, I don't know what happened. Okay, so Indian city of Nagpur, there what happened? They have uh, they have made all our cars electric cars. Nagpur city, you can see all our cars. Those cars are electric cars. They have converted existing cars. It is possible. Nobody will ask you after buying a car if you convert it to electric vehicle. Nobody is going to question you why you have converted. Okay, because that is your property. You can alter it, but there will be some clause with the higher end companies. You cannot convert a Ferrari into electric vehicle because their reputation will be damaged. But for these Indian vehicles, we can do some modification. So what this Ola has done, they converted all the car, whatever car is under their control, to electric car with some facility. All the drivers under that car went and they have changed the technology from IC engine to electric vehicle. It is used in 2019. It is still used there. We know Nagpur is the most polluted city in the country, right? So India is after China, the emission is very high in India. Because of this COVID time only, we are having reduced emission. So, but if you see, our country is basically polluted. The transportation systems are highly congested. If you are going to, let us say, in a traffic scenario in Chennai, if you want to move out with a car, your car will be stopped at least for 1.5 hours. If you are going to Chennai, it will stop for 1.5 hours. Just the engine is turned on. That means the emission. You can imagine the kind of emission. Because if the engine is turned on in the neutral position, you know there is going to be emission from the engine, right? Not only in the running position, let us assume it's a continuous operation, the emission is low. But in the neutral position, you can see it is near to first gear, or let us say it is still in the operation mode. It is going to emit for longer duration if you are stopping a vehicle. It is going to emit some carbon dioxide into the atmosphere, right? So the emission of our country is very high. After China, India is having more emission. So not only in this one, let us say your thermal power generation, whatever electricity we are getting, 70 to 80 percentage is by coal power generation. Coal power means thermal energy. So you know what happens when you heat up the coal, right? Even though they have a rolling mill to crush the coal to make it powdery form, the combustion is highly not efficient. It is not efficient at all. The carbon dioxide emission from the thermal power generation is very high. Okay, so it is going to contribute to lot of carbon footprints in the atmosphere. There is going to be lot of carbon dioxide, and the followed up effect is your global warming. Okay, so there are lot of policies coming forward to stop the emission, but we are unable to reduce our emission. We are bringing a lot of technologies, but we are still in the forefront of emission because our demand is more, our technology is poor. Our technology is very outdated. So because of that reason, you are buying electric. We are buying all the internal combustion engines, and we are not going for electric vehicles. Okay, so we have to reduce the emission. So Nagpur, they have Ola from Nagpur has taken a nice initiative of electric vehicle. Only thing is initial investment is going to be very high. So if you are buying an electric vehicle, initial investment is very high. Okay. So there is a video on electric car that I can share you later on. So, so that in that video, what it has shown is the OD, how OD car e-tron, there is one vehicle called e-tron. So that is an Audi vehicle. So that Audi vehicle, how they are using in the factory, how they are manufacturing in the factory. Okay, how many engineers are there? Where is the real engineering happening? Okay, so that you can see in the video. And important thing is your battery. Okay, so there is a separate battery manufacturing. So where I think they have used the
Pa, there was an unexpected power cut. Prakash, are you there?
Yes, sir. I'm good, sir.
Okay, my laptop doesn't have a backup, so and there is a power cut. So I will continue with this mobile interface. Okay, let me open the
Okay, sir.
PPT.
In village also sometimes it occurs weak network, sir.
In your place, huh? No, actually, I'm also nearby college only. But today morning also we faced some power cut. So updating the PPT.
In both model there is advantage and disadvantage, sir.
What?
In fuel method and electrical method.
Yes, yes. Okay, how is it you are able to understand, right?
Yes, sir.
If
I
not, is
understand.
it okay? So I'll try to use this interface.
It's easy to understand, sir, because I have learned in diploma too, sir.
Okay. What is the
So
subject you learned?
it's in diploma, sir. I
Yes.
have learned EDC and RES, sir, in
Oh,
diploma.
EDC subject was there, for years.
Yes, sir, in diploma. EDC and RES,
Oh,
renewable energy sources, sir.
okay.
That's also electrical.
Okay. So I'm opening the mobile interface. Okay. Now my mobile
Okay, sir.
interface will be shown to your screen. Can you see the PPT now?
Yes, sir. Yes, sir.
Yeah. So I will use this interface to continue. Okay. So I thought of discussing the video also, but let us see if it is possible. We will share that also. So what I mean to say is, the electric drive is going to be the future. You might have heard about Elon Musk, right? So Elon Musk is America's most powerhouse comeback. So he is the most big electric vehicle industry. He has recently released one electric vehicle, and but the cost of that electric vehicle is so high. But it is they claim it is unbreakable. Okay, and he is into this space business also. So all these space business, if you see in your space, you cannot use IC engines. Everything is working under electricity. So wherever you go in the space, your motor, everything should be spark free. There should not be any spark in the space also. So we will use brushless DC motor. So that is brushless DC motor has advantage of no spark at all, right? So that is one advantage. So here what we are discussing is Audi e-tron. E-tron is an electric vehicle. You see the factory, they have the factory, you see how the car is manufactured. The factory for the car. In Africa and all, they have something called a separate unit. What this e-tron company they had done, Audi e-tron, they put a manufacturing plant of battery in Africa because it is very cheap for them to manufacture battery there. And I think some raw materials are available in that place. That's the reason they have installed a factory in Africa. But after this COVID time period, in our India, there is going to be a lot of electric vehicle manufacturing units coming to installation, right? So coming to operation. So because many countries are finding it easy to run their plant in our country, right? Our regulations are very policies and regulations are not very strict like China or America. So we are very much favor to countries who want to install their plants, and by that we are going to have a lot more engineering jobs. That is the one of the aspects you have to think. Okay. So I'm coming back to my laptop. By that I will complete this slide and then we'll go to the video then. So next thing you want to see in the video is the drive and the car running test. What is the drive? What do you mean by electric braking? So mechanical braking, there is going to be some drum arrangement, mechanical arrangement to stop the wheel. Okay, there is something called drum arrangement or something like a plate mechanism to stop the vehicle. But it is possible. It is possible to stop the car. It's possible to stop the car. I have joined. So it is possible to stop the car. So it is possible to stop the car if you want to stop it with the help of electricity. That means your motor is completely under control of electric parameters. So you know that your motor will rotate in one direction for a particular connections, positive and negative you are giving to the terminals, it will rotate in clockwise direction, assume. Okay, if you change the polarity, motor has to stop, then you have to rotate the opposite direction. So it is the case of a normal DC motor where you have two polarities, positive and negative. But usually your real DC motor or your AC motor will have three terminals. So we call it as three-phase motors, R, Y, and P. Now, if you interchange any of these polarities, R, Y, or Y, B, you are interchanging, the motor will rotate in the opposite direction. So before rotating in the opposite direction, it will come to rest. So that is one method, reversing the polarity. So other method can be, you can assume there is some energy stored in the rotor. Stator and rotor is there, right? So stator we are giving the supply. The rotor is going to rotate. So there is going to be some electric energy stored in the rotor. So when you are going to take that energy back, you are going to take that energy back and dissipate it to some other loads, resistance, inductance, whatever, any load you take, usually resistance. So if you are trying to take the energy that is motor is rotating in some speed, okay, the motor is running in high speed and you are going to stop the motor somehow. So when you are going to stop the motor, what you can do is you take the energy source, that is voltage or power inside the rotor, drain to the resistance. So that is called dynamic braking or rheostatic braking. So the energy will be drained to the resistor, but the draining will eventually stop the motor also. Okay, so that is called your electric braking. So that braking methods and all we will see. Now one of the important area is programming, embedded system programming. You know, in any electric vehicle there is going to be some electronic circuit also. Otherwise, it won't show you the neutral or it won't show you the indicator. Its horn itself won't work. Okay. So there is some electronics or electrical system inside any car you take. Okay. So you have to program the IC, integrated circuit, inside the car. So it is programmed. Each car company will have their own software to program the IC, integrated chip inside. Why? Because these IC will tell the car when to charge, how much to charge the battery, when to change from battery to fuel engine, or when to change from, if it is a fully battery based car, when to change from some boost mode, how to boost there is some boosting mechanism if it is there, and there is some hill area, so when to convert it to boost mode, and there are some other features if you want to include now. The features, all those features and the controls are programmed by embedded system programming. That is an embedded system, and you have to program it. Okay, that is what I mean by that is what I mean by this video. So by the end of the session, I mean the preparatory class, we have like four classes. The fourth class, you have to do a MATLAB mini project. So I'll show you that project also feedback because I have that files with me. Or some other small electronic circuit you have to submit. So that is like a hands-on session, very easy to be done. So if you want to use a MATLAB file, means you should have a laptop with MATLAB installed. Okay. If you are not having MATLAB, if you don't have MATLAB, then you buy the components, electronic components, and assemble a small circuit. I'll show you that circuit also to run a motor, DC motor. Okay. To control the speed. Okay. So that is going to give a tremendous advantage. That is going to change your view of, electric applications, because it can be done by engineering students easily. You can do innovation, you can do robotics experiment, everything with the small knowledge, okay, of electrical and electronics engineering, as well as your mechanical engineering knowledge, right? So we have discussed on electrical drives used in electric vehicles. So we know that the subject is going to be divided into, your subject is going to be divided into, first you will learn about the overview of the subject. That means you will know the basic block diagram of electric vehicles, I mean electric drive. So you will get a difference between motor and drive. You will understand what is a motor, what is a drive. It will teach an engineering student how to select a drive and for what application. The subject will teach an engineering student how to select a drive, on what basis you are going to select a drive, and if the application is industry or any other area of engineering. Okay, so it will teach, next thing it will teach is what are the different types of drives available. As I was telling, DC drive is there, AC drive is there. DC we have different types of motor, so we have different types of drives there. AC you have different types of motor, so you have different AC motor also, drives also. Okay, and next thing is you will know next thing is starting methods. Okay, I was telling we cannot directly turn the motor on. We cannot directly turn the motor on. So why? Because it will damage the winding of the motor. If it is a DC motor or if it is an AC motor, if you are directly giving supply to the motor, it will damage. So you will use some circuit, a small circuit called the starting method. Okay, there is a drive is in the one side and in between there is a starting method circuit. Okay, we will see different types of circuits. So that is one of the important area you will learn. Next you will learn DC drive speed control using power electronic converters. Okay, there is some controllers called power electronic controllers. So that you will use for DC drive. Next, last you will be learning about AC drive. What are the power electronic converter used for AC drive? Because a drive by just a drive is not going to help us. You have to control that also. You can, as I was discussing, there are some characteristics in your industry. The industry load has some characteristics. So you should know how to operate a drive based on that characteristic. So let us assume you want to pull some water from the well. Okay. So let us assume you want to fill a bucket full of water. So you are lifting water from the well. Okay. And you are filling the bucket. So if you are filling one bucket, you will easily fill it very fast. You will do it very fast. You will fill it within, let us say 5 minutes, you will fill that bucket. But if you assume you have like 10 to 15 buckets to be filled, okay, then if you are using your full energy in the starting stage, 5 minutes you are filling one bucket, it will not help you because after filling 2 to 3 buckets, you will be tired. So in that sense, you have to use very carefully. You have to fill the buckets. You have to fill it slowly and steadily. So in the case of a drive, you can actually control the speed of the motor. So for a particular application, if the motor is getting heated up, let us say, I'm using a lathe machine or some application, I'm using some drive mechanism. So that drive mechanism, if we are operating in a fast fashion, we are trying to control the drive very fast, then the motor will get heated up. The drive itself will get heated up, and you may not be able to use it for a long term. So you cannot use it for a long time. So what you have to do, you have to control the drive. Okay, you have to control the speed of the drive. You to control you should know the torque of the drive. So if you control the speed, it is indirectly possible to determine the torque also sometimes. Okay. So there is one formula, very important formula you should remember. Power of the drive is given by torque into speed. So we will write it as P is equal to tau into omega. Tau is your torque, omega is your speed. So for a drive of 3000 RPM, if you know the power, you can find its torque. Or for a drive of 3000 RPM, if you know the torque, you can find its power. Or anyway, if you know the torque and power, you can understand the speed is going to be this much. Okay, it is possible. So using a simple formula, you can find a lot of parameters, right? So given two parameters, you can find the third one. That is what I mean to say is you should know that how to use certain formulas in the application. Okay, in the application level, you should know. So we will understand the overview of subject is you will understand what is a drive, what are the types of drives. You should know how to start the drive. You should know how to control DC as well as AC drives. Okay. You will understand the basic objectives of this subject. Different methods of starting you will understand. You will know how to control the conventional and solid state method of speed control, right? Solid state in the sense power electronic control, converter method. Okay. Different electrical machines, you will know the performance you can understand after studying the subject. This subject is very much important in your career because in the final year you might be doing some robotics project. There you are going to deal with the drive. So you should know the calculations of the drive used for any robotic projects. Okay. It will fill the gap between mechanical and electrical engineering. So how electrical engineering is connected to mechanical engineering. That gap is filled by studying this subject. So current trend is Elon Musk, I have discussed Tesla electric vehicle you might have heard. Just search Google Tesla, you can get a lot of material, the news from that. So you should know what is happening in the world. So Americans are building some big electric machines like Tesla company. They have built some trucks, right? So like e-tron, they have built some other Tesla vehicles, usually car companies. Okay, so you should know how they are able to build and who are all buying that machine, right? So it's already happening. It is costly, but it is very environment friendly. It's a sign of prestige. Electric vehicles are, right? So in higher studies, you will learn robotics. You know, in Harvard itself, Harvard University itself, topmost university in our world, they have a robotic subject, robotic course taught in their university. Okay, you can imagine the level of reach this subject has. So this preparatory class we will be learning with the help of PPT, MATLAB simulation, and a video. Okay, we'll show you that. And I was discussing about the MATLAB simulation environment and the hardware project, small mini project. Okay, those things I will show you. So before that, let me come back to my laptop again. The presentation. I think I'm closing it. I think we close everything. Okay, I can present here now. I'll do that. So I think I going the backup. So I'll show you. Show you that video. Just let me take that video. Prakash, I will start playing this video. If you find it
Okay, sir.
difficult, let me know. I mean, the sound is not very good because I'm going to play it in my laptop with the mobile earphone as mic system. I think it's giving an echo. Is it audible? Prakash?
Sir, ವಾಲ್ಯೂಮ್ ಕಮ್ಮಿ ಇರಲಿ ಸರ್.
Okay. So I will do one thing. I will
Prakash, I'll play it now. I'll play it in the laptop. Okay.
ಓಕೆ ಸರ್.
Please let me know if there is any difficulty.
Pushed out a few months earlier. And some of these developments and a team of senior developers needs to put the finishing touches to the e-tron. Only when they give the green light can series production begin. We said everything in figures so that we can continue. A simple system reset is enough to to make them work properly. Whether this is still feasible, we will see. John finds himself in a race against time. The road test begins. The e-tron is Audi's first all-electric vehicle and the first in the entire Volkswagen Group. With all other electric cars today, the electric drive was simply installed in the existing bodies. But the e-tron was specifically designed as an all-electric car right from the very start. And yet, electric mobility is as old as the automobile itself. In 1900, for example, around 38% of all cars in the USA had an electric drive. Car makers have been experimenting with batteries and electric engines for around 130 years. The reason they never became commonplace is simple. Gasoline was dirt cheap by comparison. Audi and its predecessor brand, BMW, also developed many electric cars that never made it to series production. But that chapter is finally being written now. Es hört sich extrem cool an. Very cool. As far as I'm concerned, I came to scale it over 7,500 metric tons of steel installed here. The same amount as the Eiffel Tower. Das Masse an Stahl in den Eiffelturm. And there's another big challenge. Brussels is the first automotive plant in the world to have a battery production line installed. More unknown territory. The cells that arrive are bundled into packs in a largely automated process and combined in an extremely rigid frame to create the final battery.
This is the winding. What they are doing is actually the winding for the motor. Okay, so separate winding they are doing for the motor. So I'll change the HD because it is coming a little bit delayed to some 350p. Okay, so now it will run smoothly.
Audi is ramping up its own electric engine production facility. Another unfamiliar area for a car maker. But Audi wants to make sure it keeps all of the future expertise in-house. Audi is also developing the batteries itself. At the battery test plant in Ingolstadt, the individual cells and the finished batteries are put through their paces. We do different kind of tests. For example, here we do some kind of thermal tests. So we stress the battery, we charge them, we discharge them, and try to find out which situations are really important for the battery, for the lifetime, and for the safety of the whole system. Before the car can hit the road, another test is required. The battery has to be absolutely bulletproof before the road tests can go ahead. The e-tron, the electric engines and the battery are installed where the engine, drivetrain, and fuel tank would be found in a conventional model. But one thing is the same for all cars. Safety is the top priority. Audi is dedicating vast efforts to this area. Safety problems are something it cannot afford as it enters the age of electric mobility.
Also die Unterseite ist alles in Ordnung, schütze dann auffallen und der Verkehr passt, oder?
For this car, the technique is pretty new to all of us. We did some more crashes, it's almost 80 crashes. Project manager Jens Van Eyckels' car, the charging.
Ja, ich hatte hier eine Fehler.
I got another error message saying that the charging plant had been initialized correctly. So we're taking a look at what the problem was.
Der Umgang.
Okay, all fixed.
Okay, there what he is doing is actually the car has faced some charging problem issues. Okay, so he has solved that problem using his laptop. He has just entered the program and it got rectified, right? So you can see there is an embedded programming there. So embedded system IC is there and the IC has to be programmed. So there is an embedded programmer, right? So for a car.
Let's get it back on the road. The e-tron recuperates almost every time the car slows. And not only in cruising mode. The electric engines feed energy back into the battery almost every time the normal brake is operating. To present this revolutionary concept to the public, Audi invites international journalists to a location that occupies.
Okay, here what they are explaining is something called electric braking. So whenever the car is running due to the momentum, due to the kinetic energy, due to the motion of this car, the power from the wheel is actually transferred, power is transferred, right? The power is transferred through the power transferring mechanism and to the motor. Okay, so the motor will act as a generator here. Okay, it can act as a generator and that power is charged to the battery. You can see this is the battery. Okay, this here they have mounted on the chassis itself there is a battery. So this is, they call it as recuperation, but we will call it as electric braking. Okay, so this kind of braking is possible. Now due to this electric braking, it's called regenerative braking. The power is regenerated. Due to this braking, what happens? Whatever power is obtained from the motor, I mean obtained due to the motion of the car, can be stored in the battery and we can take that power back again when we are in need of power. Okay, so let us say due to this regeneration the power is stored in the battery. Whenever that we want an extra pull to the car, we can take that stored energy back to the motor. So here the important part is this motor can act as a generator also. Okay, so it is called a regenerative braking.
Has a special place in the company's converting kinetic energy into electrical energy. Recuperation protects the brakes. The electric engines slow the car. What this means is the electric cars of the future will cause very little in the way of brake wear and tear. It's true, the competition never sleeps. source electric customers in the premium segment is extremely tough. The pioneer in the field, Tesla, has now lost much of its mystique. Production problems in particular have damaged its image. Things are moving quickly at the established manufacturers. Jaguar is launching its first all-electric SUV, the I-Pace. In Germany, too, electric mobility is really starting to get moving. Just like the Audi, the Mercedes EQC was presented to the public in the fall.
Here it is.
The technical concepts for all three cars are very similar. SUV bodies, large batteries between the axles with a capacity of up to 100.
So you can see the battery pack there, okay. So the batteries are very large.
Kilowatt hours, one electric engine at the front, one at the back, and a range of over 250 miles as standard. In 2019, Porsche will join the market with the Taycan, whose performance specs are said to be even better. Seriously tough competition, in other words.
That is an Audi coming for charging. Okay, they are opening the socket for charging and it will be good for charging.
The deciding factor could end up being the best charging strategy. Audi has the advantage here, as the e-tron can be charged at up to 150 kilowatts, making it ready to drive again quicker than any other car right now. To illustrate this, Audi is arranging a very special event in Berlin. At the Siemens High Voltage Laboratory, several 100,000 volts are used to generate some spectacular visuals.
So they are increasing the voltage. Okay, they are assuming they are doing some testing on the car because it's an electric vehicle. So you have to test the electric vehicle. That's a actually there is a big transformers here. So high voltage transformers. A moment back you might have seen a screen. Okay. So that is the voltage level. You can see 199 kilovolt. Okay, so that's a peak voltage they are building. Okay, so there is a high voltage generated for testing the car. You can see that.
But the main aim is to inform the public about Audi's future charging strategy. Simply building an electric car will not be enough. To this end, Audi and other manufacturers are working together to establish a dense network of fast charging stations throughout Europe. Andreas Klemm's team starts work with charge before hitting the road again. Meanwhile, at the Windtunnel in Ingolstadt, a new test series is being prepared with prototypes. Gerhard Bigard believes he's found a solution for his aerodynamic problem.
Ja, wir haben bei den Prototypen
In testing the prototypes, we realized that the seal around the radiator section isn't doing what it should.
hier das zweite Auto, wo
Now we have a second car with a new radiator seal that we developed additionally.
eben extra,
But it wasn't really any better.
das war jetzt nicht wirklich besser.
The pressure is mounting on Gerhard Bigard. A solution needs to be found in time for the start of series production. Time is running out. I'm a natural optimist, but I never rule out the possibility that something will go wrong. The first For achieving this takes considerable effort in the area of thermal management. The safety of the cells also needs to be guaranteed, and we obviously want to be able to demonstrate the full performance of the Audi Quattro right from the start. Smoothly. Schwierigkeiten auf Eis mit Temperatur on ice and snow if the friction coefficient is very low. So the ES.
Okay, this is the extreme temperature, I mean low temperature working testing of the OE. Okay, you can see it is pulling some load and it will test for charging also because it is sub-zero temperature, right?
These engines have to be calibrated with great precision in order to stabilize the car in a pressure combination. And oscillation increases, and you can see the brake intervention there. It's crucial that the e-tron is a real Quattro, albeit built on entirely new technical foundations. A real challenge for the drive developers. The main difference in terms of the e-tron Quattro all-wheel drive is that it uses two electric engines, one on the front axle and one on the rear axle. This gives us development in the rapid control dynamic of the electric engines is especially useful. Even in Lapland, the Quattro makes for an enjoyable drive.
Okay, so I hope that is an interesting video, right?
So,
Okay, so we'll continue with our session. Let me take out the other files I want to share with you. So since it is an introduction, right? It's coming back. Okay, so I have shown you the NPTEL industrial drive video, and there is some electric vehicle video link that also I have shared. Now we have the assignments, right? So there is something called MathWorks. So that is the MATLAB. Actually, it is belonging to MATLAB. That's a community where you can uh, find certain models. Okay, here we are going to see brushless DC motor. Okay, an introduction to brushless DC motor. Brushless DC motor control, brushless speed control using pulse width modulation. PWM is pulse width modulation. Understanding the field oriented control. Okay, so these four video as well as the models. Okay, you can download the file itself. Okay, so this video is supported with the working model. So I want you to download that video. It's a MATLAB simulation file. Okay,
So I want you to listen to this video as well as download that video, download that file, and work on that file. Okay, here she will explain brushless DC motor very nicely. Okay, and she has shared one file also. Okay, so that file also can be downloaded. Okay, in the I mean four series are there, right? So I think in the last file, in the last thing you can download the file. Okay, so what I mean to say is I will share you all these files. Okay, brushless DC motor. Initially she is giving an introduction about brushless DC motor. Even though it is not at all connected to your syllabus, you will understand a lot of things from these videos and simulation, right? So how to control the motor using control techniques, speed control methods, right? And the field control, how they are doing it. It's all very advanced area of engineering only, right? So I want to share you that. Along with that, I have some other files. So this file, we extract it. Okay, these are the simulation models. So SLX file is there, no? That is a simulation model. So you can open that files in the link. Okay, it is already there in the link. .m file is the script file. .m file again. And here is the SLX file. It's a simulation file. So PWM control method file. So I want you to open this in the MATLAB. I want you to work with that assignment, right? So that is my last session, fourth session. I am telling it in the first session itself. You have to work with that. I will share you the, PPT, the model files also with you, right? So that you can easily work on to that. Okay, so I hope that is an interesting session. So if you want to ask any questions, you can ask. We have like 20 more minutes. Prakash, let us discuss something. Prakash, are you there?
Sir, I'm not sure.
Okay. இது புரிஞ்சுதா இன்னைக்கு என்ன கிளாஸ் புரிஞ்சுதா உங்களுக்கு? Did you
புரியல
understand?
சார். Sir, I understand, sir.
Today's session, was it interesting? Interesting இருந்துச்சா?
Yes, sir. Because it's a mechanical subject, sir. So.
Okay, you like mechanical also. Okay. Actually, it is maximum electrical also coming. Electrical and mechanical. So 60% electrical தான் ஆக போகுது. Mechanical in the sense concept of mechanical braking. Some area it's mechanical, but not all areas are mechanical in the subject. But application is mechanical, purely mechanical. Whatever electrical drives you take, outcome, what is the output of a drive? Motor, speed and torque, right? Those are mechanical parameters. So output is mechanical, but whatever we see as
Input is
side is
electrical.
electrical.
But it
Yes.
comes out
So
mechanical energy.
output as mechanical, yes. So that is what you want to understand about the subject. When you join your friends, you tell them this video is been recorded for the first class. They can listen to that video. When the video is shared to them, we will share it. Okay, the video is available like that. You tell,
Okay, sir.
because it is very good. I think it's a good introduction for the subject. The 4 day session will be very interesting for the students, because if they find it difficult in the starting, this video will help actually. Because when we say about engineering subjects, your friends may be afraid sometimes. I don't think everyone is happy about subjects. Okay, so only such classes are being introduced to bring some interest in students, right? So anyway, you can discuss with your seniors also. If you are interested, you can collect materials from them, because as of now we are not advised to share you the materials. You can start studying if you want now itself, if you have time. Then of course we will be sharing all the materials whenever the class starts. We will be sharing you all the question banks. We will share you the important questions. Okay, we will share you extra material whatever is available. Previous year question papers we will share. So everything will be shared with you. It is up to you to ask us about doubts. It's up to you to organize. Uh, start doing some projects or something like that. Okay, so don't have to worry about asking any questions. Don't hesitate to ask any questions. Right. So anything else you want to share means uh, I will ask you to share now. So I will do one thing. I will stop the recording. Okay.
Okay, sir.
Recording.